All right, welcome to our 8th video of Unit 4. We're talking about standard enthalpies of formation. So, the standard enthalpy of formation, which typically is denoted by delta HF with that little 0. That 0, by the way, represents standard, and the F represents formation. So, you'll see both of those for a while. Anyways, of a compound is the change in enthalpy that accompanies the formation of 1 mole of a compound from its elements with all these substances in their standard states. Meaning, it's like if you're forming water, typically the equation is H2 plus O2 produces 2H2O. There's a 2 over here. So we're saying it is the energy that forming 1 mole of water. So actually, in this case, that would have to be reduced down to a 1. That means that's a 1/2, and that's a 1. So it's the energy required to make 1 mole of water from its constituent elements. That's the standard enthalpy of formation. So first off, the standard enthalpy of formation, again, standard enthalpy of formation of elements is 0 Kelvin. This is a block of sulfur. You don't need energy to find a block of sulfur. It's already its element. There's nothing making up sulfur. That's why it's an element. All right. For reactions that occur at standard conditions, we can easily calculate our actual enthalpy of reaction by using an old formula of products minus reactants. I'm honestly not really sure why I told you this earlier. You didn't really use it till now, but whatever. So our enthalpy of reaction basically is just the sum of the enthalpy change of our products minus our reactants, meaning add all the enthalpies of formation of our products and subtract that from all the enthalpies of our reactants. That's it. So in this case, we're finding the standard heat of reaction for the reaction of CO with O2 to form CO2. Step 1, make a reaction. CO plus O2 forms CO2 as a gas, and we got to balance this. That gets us 2, 1, and 2. If they had said the standard heat of formation, like literally use that phrase, this would just been a coefficient of 1, and we'd have to balance it. They didn't really specify that. They did say standard heat. However, that implies the conditions it's at, meaning it's kind of at like room temperature and a few other things that we'll talk about next unit. But yeah, so in this case, we're going to find our actual enthalpy values for each of these and then do products minus reactants. So carbon dioxide, if you look on that chart that I gave you, has a standard enthalpy of negative 393.5. Oxygen is an element. That means it's going to be 0. And carbon monoxide is negative 110.5. Hopefully you remember that our delta H of reaction, which is basically what we're solving for, is equal to our products minus our reactants. So then our products are going to be negative 393.5 times 2. That 2 coming from the coefficient. Minus our reactants of negative 110.5 times 2 plus 0 times 1. I know that 0 times anything is just 0, but still, just for the practice. All right, when you multiply those out, you get. So I'm going to let you pause, try this reaction a bit, come back in a few minutes. Okay, so let's make first our reaction. We have NO plus O2 produce NO2. It's kind of the same equation, so it's kind of boring. Sorry about that. Could you get 2, 1, 2? All right, so NO2, however, when we look it up, gets us 33.84. Oxygen again is 0. Nitrogen monoxide is 90.37. All right, so our products then are going to be 33.84 times 2 minus 90.37 times 2 plus 0 times 1. Put that in your calculator and you get negative 113.06 kilojoules. And that's it. That's really all these problems come down to. Just find your equation, find the values they gave you, plug them in. Try to remember that elements are always going to be 0, but that's it. Here's some practice. As always, thanks for watching. Please keep in mind you need to balance them first. You should be able to find all these values on the chart that I gave you. But yeah, thanks for watching.